Hello, sir. Ramesh, sir.
Sir, yes, sir.
Shall we start the session, sir?
Yes, sir. Yes, sir.
Okay, fine, sir. So, good morning to all. Say warm welcome to all the participants of a AHD sponsored faculty development program on design thinking organized by Department of Mechanical Engineering, Sri Manakula Engineering College, Puducherry. So, first of all, I extend my warm welcome to our speaker, Professor Dr. Ramesh Raju, Department of Mechanical Engineering, Santhiram Engineering College, for accepting our invitation and be part of our FDP program. So now it's time to invite Dr. Pandian sir, Professor in the Department of Mechanical Engineering, to welcome our today's speaker. Good morning, one and all presented here to attend the ATAL AICT sponsored faculty development program on design thinking organized by Sri Manakula Engineering College. On behalf of the principal, director, the management, the HOD Mechanical Engineering, I would like to introduce today's eminent speaker, Dr. Ramesh Raju, sir, who is working as a professor and head in the Department of Mechanical Engineering, Santhiram Engineering College, Nandyal, Andhra Pradesh. About sir, he has finished his UG in 2003 at Shanmuga Engineering College, Tanjore, and is a PG at the Tyagaraja Engineering College, Madurai in 2006. After that, he had obtained his PhD in the field of mechanical and microstructural studies on a laser metal deposited nickel and titanium based aero engine blades from National Institute of Technology, Tiruchirappalli. And he holds the working experience of around 15 years, which includes teaching around 8 years and industries 2 years, and as a software engineer for 5 years at Cognizant CTS in Germany. After his return from Germany, he joined as a teaching profession and started his career to serve for the society. And he has a good publication backup. Around 35 international and journal papers he has published and attended and organized around 30 conferences, both national and international. And he delivered more than 10 guest lectures in various institutions all around India and attended the STP, FDP around 25 numbers. And his main research field is on material processing, laser machining, surface engineering, and tribology. He has visited the countries like Germany and France. He received awards as a best reviewer from Elsevier and Vacuum. He holds 2 patents and he is the author of 2 books. And he is a fellow of Indian Institute of Production Engineer and a member of Indian Society of Technical Education of India. And he is a regular reviewer of the Vacuum, the journals like Vacuum, Journal of Testing and Evaluation, International Journal of Information Technology Project Management, International Journal of Mechanical Engineering and Application, and Material Science and Engineering. So today we are having an eminent speaker, Dr. Ramesh Raju sir, professor, to have a delivered speech on the topic of model thinking. Hope the participants will enjoy the session and get benefited from his speech. Sir, Dr. Ramesh Raju sir, the dais is for you, please.
Thank you, sir. Thank you, Professor Pandian sir, for a brief introduction about me. And first of all, I would like to thank the principal Director and Management and Head of the Department of Mechanical Engineering, and my beloved friend Dr. Tyagarajan sir, for all giving me this opportunity to deliver my content, especially in the ATAL FDP program on design thinking. So I take it is my privilege to represent as a resource person for your eminent FDP program. So again, once again, I thank you all for giving me this opportunity, and I welcome all the participants for this program. And here I'm going to deliver a topic under model thinking. So though the topic is not that much easy to confine within short duration of 1 to 1.5 hours, I will try my best to give the more insight about the content. And I hope you may be enjoying the session. So whatever the things you wanted to ask, we will have the interactive session at the end of our session. Okay. So thank you, sir.
Thank you, sir. Thank you.
Sir, shall I share my screen, sir?
Yes, sir. Yes, sir. Now you can share.
Yes, sir. Yes, sir.
Yes, sir. Let me. Sir, is this visible, sir?
Yes, sir. Yes, sir. We are
Yeah.
getting activity, sir. Yes, sir.
Thank you, sir.
Thank you.
For time being, I just mute my video. So I'll go with the presentation now. So fine.
Yes, sir.
This is the model thinking. So, and mainly the model thinking is a subset of design thinking. I hope the previous sessions in this program, there are a lot of resource peoples from Patsardi, Palnisar, and everyone. I hope they might have given you deep insight about the design thinking. So what is the design thinking normally? It is a roadmap to the innovations. So why we are repeating the concept of design thinking is to move towards some innovations, right? So normally innovation is something which we are finding a new, which is going to be useful for the humankind or the society what we are living now, right? So normally innovations can be happen in different ways. So different ways, either it may be like a through proper vision. So vision in the sense, you might be taking the example of Henry Ford, who had a vision of his automobile. When he converted the two-wheeler to four-wheeler, everybody, they just started laughing. Is it possible? How it is it viable like that? But he's the person broke all the things with his proper vision. So Henry Ford is one of the visionary guy whom we can easily refer. Anybody can able to say. Steve Jobs. So because of him, that Apple, iPhone or iPad, we can say. And similarly, Elon Musk, the guy who is now is ready to send a human to a Mars, which means a common people to Mars. He is a planning. So SpaceX, right? This is the visionaries. So like that, innovation can able to or can happen by means of these type of visionary peoples. Sometimes innovation may happen through luck. So how can we say it is accidental innovations? So the best example is, we can say, the microwave oven, right? The microwave oven what we are using, it was a one of the accidental innovation by a scientist who was working with the microwaves, right? When he found the candy was melting in his pocket, then he got the idea. okay, this wave can able to produce a heat which can be used. The same way, Teflon coating, which is in non-stick tawas. So whatever in our kitchen utensils we are using to make it to non-stick. So the Teflon coating is also a accidental innovation. When they were trying for something else, they found a polymer material which can heat resistant as well as water resistant. So like that way, Teflon, even the automobile, car, wheel tires, the tire material is also a kind of accidental innovation. So like that, many things are there. So many things, especially if you are considering the food products, the potato chips, it is also an accidental innovation. So this is one type. When we are moving towards the innovation, either through vision it is possible or accidental it is possible. The third category mainly falls with the design thinking, which is the process, right? So the process can bring out some very good innovations. So that process can be defined by means of design thinking. So that design thinking, normally if you look at here, it is having various steps. It is depends, right? So how we are and what application we are considering, accordingly it can be having a several steps. But in overall we can make it into a three, which is defining, acting and reflecting. That would be the three stages for design thinking. So whenever I am going to define, I supposed to say whether empathize and then define. So it will be like a starts from a storytelling, and then it will be a making into the empathize. So we have to get the feel, what is the thing we have to address, we have to discover, right? So that, and then it will come with the defining. So what is the opportunity it is having? So this is one. And then next one, acting. Act in terms of either we have to learn the things and ideate. After ideating we have to go for testing and sharing, right? So the prototype development, testing, everything will be the another phase, which is acting, right? And then finally it will be reflecting. So reflecting what we are doing. So with that we are going to iterating the same steps again and again. So this process is a continuous loop, right? So here it is not at all a, it is a not at all a linear one. Instead it is a non-linear as well as iterative. So this process is the design thinking. I hope in your previous session, so almost everybody might have addressed about this design thinking process and the concepts, right? So I'm not getting into much detail about this. So the picture what you are seeing, it is explaining the stages of design thinking in your workplace. So whatever the work we are doing, right? Say for example, I am just going with one new idea. I have to concentrate on one new innovation or new somewhat improvement. Then what I have supposed to do? I have to go with the teamwork. So where I have to list what would be the problems it may come, like a storytelling, right? So we have to tell the things, and when we are addressing the problem, first we have to put ourselves in that place. So that is empathize, right? Putting ourselves into their shoes and looking through their glasses. Then we will get the what type of problems we may encounter, right? Then we have to make it into a short note, and we have to make it into a collective of all the things. So when a team is going to address one single problem, so every person to person, they will be coming up with the solution in a different defining, right? So then we will go with the collecting all the things, and then we will be making into a ideating, which means ideas. So with respect to different ideas, again we will go and we will try with on a prototype, right? So the prototype and the testing is the main and mandatory. Why? Because if we go with the prototype, we can able to easily get a failure at the earliest. That is the most important thing with respect to the process. especially innovation process, because as early as we get failure, we can able to again learn very quickly. Why? Because this process is a loop. It is a non-linear and it is iterative, right? So every iteration, every mistakes will be rectified and it will be fine-tuned, and again it will come with the proper optimized solution, right? So this is a design thinking process, what we have seen in nowadays. So normally this design thinking is highly related with the industry 4.0 concept. So it is not only for management technique or not only for engineering solution, it is highly related with the industry 4.0. Why? Because it is more and more linked with the digital transformation. Why? Because industrial IoT. So with this, if you see one ad, right? So recently you might be came across with the ad, right? So this is a Cadbury's ad. I hope you can see.
Sir Ramesh, sir.
So this is the one of the ad. I really felt very excellent the way they created this ad, right? So I hope many of you might have gone through this ad, right? So have you ever wondered what is the technique they have used? Why we are praising this ad like anything? So if you look at the ad again, the same ad was came with the promotion also, how they have done, why they have done, right? So when that they came, then we see how best they use the design thinking concept in their model. So it is like not only for a single advertisement, it is with the human centric method. So they are addressing the social responsibility in their ad. So it is one among the best, what I feel when you look at here again.
So Ramesh, sir.
Sir, yes, sir.
But we are not getting the audio, sir. What we are
Oh,
playing,
audio.
we are not
Okay.
getting the audio, only the display.
Only you are getting the
Getting the
screen.
screen only, we are not getting the audio, sir.
Okay, 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 sir. The thing, okay, I will explain. I will explain this.
Okay, okay, okay.
So here in the video, you can able to see a different store's name is reflecting. So here it is not only the one store, because though it is a Cadbury's ad, they are taking different stores also to support. So here it is a one of innovative idea which Cadbury's came up with this time, right? So when you look at this ad, so they are not only supporting their things, rather they are going for extending their helping hand with all the small shops. This is one, sir, Tyagarajan sir.
Okay, sir. Sorry, sir.
Okay, okay. So this is a recent time I came up with this ad, especially in this pandemic situation, how really innovative ideas can come out and how it makes sense with the society, right? So these things we are getting from this ad. If you want, I will play it again. Sir, Tyagarajan sir, shall I play it again?
Okay, sir. You can play once again.
Yes, sir. So when I'm playing, you can see let me check. So at Diwali celebrations, normally Cadbury's used to come up with their ad for sweet. You have to take like that, like that. But now, this pandemic situation, many shops were shut down for a long period due to lockdown. And for them, it is financially and economically, they are suffering a huge loss. So how they can be supported? This is the one among the idea which was brought up at the Cadbury's design desk. So where they found out to support a small supporters using a small things, whatever they are showing inside, right? It is a one of the things. So just the same video, but they are showing different shops. So if you look at the product is also different, and what they done using the technological advancement, they shorting the pin code. So whenever you are watching this video in a YouTube or any social media, you might be given your location. Using that location pin code, they will pick up whatever the shops near to that area, and only that shop name will reflect here. So when you open this video here, say this is the ad in different location, different shop name comes. Video is same, however, shop names are different. That is depending on the user's end. So this is shop at Mumbai, Delhi. This is at Pune. This is at Jaipur, Indore, and so on. So if you look at here, they are excellently supporting all other small vendors also. So if you look at here, the idea, right, how it is innovated, it is not only from one thing. It is not only just a ad, also it is giving a lot of AI concept so that they can effectively use it to promote many things. So I feel this is one among the ad in recent times which came up, which was best suitable for the design thinking process, right? So whenever we are discussing about the design thinking, then I said model thinking is the subset. We cannot able to see design thinking and model thinking as a two different entity as long as we understand clearly. Okay. So what is model thinking? So as much now up to this, you might be seeing design thinking and what is interior and everything in your previous sessions. So today we are going to discuss specifically about the model thinking. So what is model thinking? It is actually deriving ideas and insights from lot of different fields. Okay. So model thinking is normally a deriving the ideas. So whenever we are going for the brainstorming, you will be getting a lot of ideas, right? So when you are collecting all the ideas, you will be getting a big insight, right? So the big insight is possible whenever it is collection of ideas. So normally it comes out from the combining ideas from different area. So this is what you might be seeing in our previous ad. So in that Cadbury's ad, what is the different things they have involved? They have taken their promotion, which means their product promotion, which is a chocolate, right? Apart from that, for making of that video, chocolate alone won't occupy the entire video space, right? So there might be some characters, they might be playing some role, they might be using some things, products inside. So in all the products, they just diverted their focus, and then they just make use of those products for promotion also. So here it is a different areas, and again it is came into that. And technology, if you look at the technology, it is not only the photo shooting and editing. Apart from that, they are using the concept of AI. So according to your location, it will be giving the exact stores near to you, right? So this type of techniques now you can see in your YouTube videos also. So whenever I'm in my mobile, I'm watching YouTube videos. So based on my selection, based on my preferences, right? So what the next time it will do, whatever the things I like, only the more and more related to that particular taste of my videos, it will show again. So for example, I'm liking more and more music. So it will show more music. And especially when I waking up, I'm just listening some particular devotional music. So every day morning, it will show me a devotional music collections, right? And at the night time, I'm just going and just I'm listening some melodious music. Then it will show melody music at the night time. This is now happening in YouTube, right? If you are keep on going and watching all these things, you can able to see and you can able to feel the difference how YouTube videos are bringing in our mobile phone. Okay, how it is possible? Because of the AI concept, what they are inherited. The same way nowadays, many of the mobile applications also floated with the similar concept. So one of the thing, right? So what we are seeing nowadays, so any app, so the app coding app, or it could be an educational app or anything, what they are doing, they are using these things, AI concept, so that a user can feel easy as well as very friendly. So easiness in the sense he may not find more difficult to use the videos or handling with that videos, right? So this is the concept, AI concept. It was used for using these things. We need a perfect model thinking, right? So whenever we are going with the model thinking, it will make us more intelligent in designer, and it will make to think very clearly, right? And to use and understand the data, and finally to decide and strategize the decision making. Okay. If our model thinking is perfect, then we will come up with the very successful product, right? So the main purpose of model thinking is to come out with the successful product. So in your screen, you can see two different picture. The first picture which you are seeing is what is the failure model, right? The failure of model, it happened. Why? Because there is a lack in coordination, or lack in information gathering, or lack in understanding or strategic planning, right? So when there is a two bridge, it's supposed to be connected, but due to lack of all the things, it was totally a failure model, right? So if you look at the next picture in the screen, right, it is the one of the micro scale heart which was implanted in a 16-year-old boy in Italy, right? So the boy was survived 12 days, almost 12 days, until he get the heart transportation from his donors. So please think here, this is the what a tiny device, right? It is considered one among the very small, a tiny heart which helped a human to survive for a minimum number of duration, right? So almost 12 days, a 16-year-old was survived with this artificial heart pumping. So normally this is the, again, you look at here, this is example for the successful model. So here, what are the things they consider? They first found out what is the material it is made up of, right? And what is the functionality it's supposed to deliver, and where we are going to use it in the place of inside. So a body fluid, everything is considered here. So they made it this material with the titanium, right? So this is the tiny heart implant which was used in the human beings, and it is made up of titanium, and it was there in his body for more than 10 days. So almost 12 days the boy survived with this tiny heart implant. So here it is not that much easy to come up with these type of ideas, right? So it is a called innovation. Here the innovation mainly addressed by different areas. So what are the areas? The material which can withstand, and the functionality, and the mechanism, what it has to do, how it has to pump, and then finally the almost important thing is the lifespan, right? So all these different aspect makes a model into a perfect in all the aspect. So this is the way a model thinking is coming into the picture, right? But when you look at the model thinking and design thinking, they seems like two different entity, right? So if you look at the design thinking, normally it is human centered process. So design thinking, whatever the things they have discussed in the previous sessions, they might have told, right? So the design thinking, the ultimate goal is to create a innovative, user friendly product and services. That is for design thinking, right? So before to the model, I'm just telling you the system thinking, right? So here we will be considered as a system thinking instead of model thinking. I'm just representing with the system thinking. So what it is doing, a design thinking is perfectly human centered process, whereas engineering system thinking is perfectly a machine thinking, which means a process oriented, right? So here what it will be doing, mainly it is going with the machine to machine interaction, how a machine supposed to interact, like that way it will be processing. So design thinking is a human centric process, whereas engineering system thinking is a system centric process. So system here, it represents a machining and machine concepts. Okay. This, if you look at these two, right? So based on the history, value, and their applications, they are normally looks into two different entities. If you look at the design thinking, it is having the origins from the industrial design and engineering design, product development, and psychology. So all these things are the origination for design thinking. In that way only we started telling about the just our defining our empathy, and then we are ideating, all the process are coming with respect to human centric. Whereas if you go for system thinking, especially engineering system thinking, so it is originated based on the cybernets and the management science operating research systems. So it is purely system specific, system based approaches. So this is the reason these two are considered in general as a two different entities of a thinking in the process stage, right? So here if you look at the values, especially in the design thinking, here it normally use the empathy, innovation, right? This is the way it will come up. Okay. If you look at the system thinking, it is normally an interaction with one system to another system, how it is connecting with each other, and then interdependence, how it is depending with the feedback from that system and how it is reacting, right? So here system is looks like a totally different than design thinking. Okay, up to certain extent, until we are not understanding completely. This is the outside view how a design thinking and system thinking will look in an aspect, right? So now when I go with the somewhat, right, comparing, whenever I move towards the comparative concept models, then I can able to see there may be something similar between the design thinking and engineering system thinking, right? So though I know design thinking is a closed system where I am going with the iterating, so number of iteration, based on that innovation will comes out, right? based on the closed systems, and I am having the boundaries, and then I am deriving my prototype and testing. After testing, I am just finding out the final human-centered solution, right? Whereas if you go with the system thinking, it is a machine to machine interaction. So it is normally considered as a open system. It is not like a design thinking closed system. It is somewhat open system where it has the interactions. The more and more interaction will make the system more and more robust, right? So that's a reason it will be going always with the more interactions. And then from that interaction, it will be concerning what is the system and how it is connected with others. So it is purely system centered and problem oriented. Here design thinking is a human centered, solution oriented, whereas my system thinking is a system centered, problem oriented. So though it looks somewhat different in concept, in what way it is looking alike, right? So when you see very closely, we can find out it must be having a creative, a flexible, a curious, and somewhat emotional intelligence. So these are all the common factor I can identify between a design thinking and system thinking, right? So this is the model. What is the first stage to second stage, right? In first stage, it was a distinctive concept model. In second stage, it is now coming as a comparative concept model. So the comparative concept model explains how the design thinking and system thinking are coming into a single part or single place, right? So with respect to creative flexibility, here I can able to see where and all it is coming into the picture. It requires similar cognitive skill set, right? So whether it may be a design or system, whatever it may be, if it goes for a thinking process, then it required a similar cognitive skill set, analogy or ability to overcome a fixation, all these things, right? And similarly, it required the same. Here it may be empathy, but faculty for human relations, right? At the end, what we are going to do after system-centered approach, it is going to help to solve some problem, right? It is going to help to solve some problem. So again, it is a connecting with the solving in empathy or faculty based. So human relations. And then similarly, individual or team level in engineering or business and education, it is having the inquiry, which means it is also collecting the all the parts which can be uh, like a curious. So what all the things comes out under the curiosity, all these things, and emotional intelligence, right? So here either from individual or team level, what you are collecting the ideas based on the intelligence. And intelligence, how it is, in the case of design we are putting empathy, right? So here it is also emotional intelligence. Here also you are going to think about how the system supposed to respond, right? Again we are thinking as a system. So all these aspects are bringing the design thinking and system thinking as a somewhat comparative model where it can be having some similarity index, right? So this is the stage which is explaining the model is comparable and it is not a separate entity, right? Then whenever come to next stage, whenever I'm understanding some more in depth, some more in a detailed manner, then I can say this is not as a two. It is neither a distinctive nor a comparative. It is a inclusive concept. So what I'm telling, the system thinking is not the standalone process. Instead, it is the subset of design thinking, right? So here I'm telling my system thinking is not at all a standalone. So it obviously comes as a subset of design thinking where I can able to see my system thinking will be encountering with the cognitive process. From that, it will go for the recognizing and interdependence, right? So these are all the stages which is possible whenever it is a subset of design thinking, right? In design thinking only, normally in design thinking, if you look at here, it will be having a human centric perspective, right? And ambiguity, and then it will be making the ideas as a tangible process, right? But if you look at here, it is somewhat subset, but still, if you look at this, the system thinking, right? Here system thinking, it does not emphasize tangibility. Okay, here it won't emphasize the tangibility, especially through prototyping in the same way as design thinking. That's the reason it is becoming a subset rather than the total model, right? So here design thinking, where it is making the ideas tangible, right? So here it is emphasizing the tangibility through prototyping. So that is the reason it is having the different way. A different way in design thinking, it is different, and engineering system thinking, it is different. This is how we are interpreting how the design thinking and system thinking is playing a role between each other. Okay, and when we do a deeper analysis, then one can able to say it is the integrative concept model. So design thinking and engineering system thinking is the integrative, which is integrated with each other. Okay, up to now you might be discussed about the design thinking in various places as because of human centered process, right? And now you can able to understand that human centered process, and in model thinking or system thinking, you can say here in system thinking, a system centered process is coming as a single entity. So previously it was two entities, and slowly we have seen how it is merging, and finally how it is becoming a single entity for any process. So that's the reason, if you look at here, design thinking, what it's required? It required a successful design, consumer products or complex systems, everything, right? And if you go further, it is also having a similar inquiry, definition, purpose, cognitive and social processes, right? And finding empirical studies on the designer thinking, and especially large scale complex engineered solutions designs, right? Whenever we are going with the large scale complex engineering, right, systems, so whenever we go for large scale, then design thinking with system thinking supposed to be integrated. Okay, if it is integrated both together, then only we can able to get a fine tuned, a problem can be solved. Okay, a solution can be obtained. So if you look at the LSCs, which means large scale complex engineered systems, almost it deals with the military industrial systems, right? So whenever we are going for the military industrial systems, it should be robust in nature, right? So that's the reason a model thinking always, it brings out the a robust concept through a design thinking approach. Okay. So if you move further, here you can able to see, right? So this is the two process. What the two process in a manufacturing way, you can say one is subtractive, another one is additive, right? So if you look at the two process, so here again it involves with the thinking, right? So what type of thinking here? I'm approach. What type of approach I'm going to use it, right? So why do we need that process? Here a subtractive, which is very old process. If you come to additive, that is somewhat advanced process. So in a manufacturing itself, if you look at the subtractive manufacturing and additive manufacturing, these two are came up in the different era, and subtractive is old, additive is a new. So here, if you look at the things, so many of the times we might be thinking, so what's wrong? Additive may be a somewhat cost, maybe more, or sometime you may be finding like subtractive is somewhat lagging in approaches, and the fine way is going with the additive. Yes. So whenever we are going with these type of things, okay, it will help us to fine tune our ideas to go and selecting the right process at right time. Okay. So what is the main concept in this? What is the selecting correct idea? What is the thing? If you look at the Nokia, right? And Nokia mobile phones, they were like pioneer, and even they were very successful in mobile market during the 2000 1999 to around 2007 8. Okay. So up to that, they were almost in the world 50 percentage of the mobile user were using Nokia mobile phones, right? So when they were using Nokia's, so Nokia was having very short-term goals only. They just developed, they upgraded the same model in next levels. So they also done the design thinking, but the ideas are very restricted. So from the middle management to upper management, whatever the ideas they were promoting, they were restricted to only development of a model, which means from one level to next level, right? When the year 2007 Apple introduced, right, when it came into the market, when the Apple phones started coming, by the time very few were there to go with the Apple iPhones or Apple product, right? Hardly, it was only they had a 2% of market, right? But when they came to the market, they were very new and very fresh. And even their operating system, it made like it is a smartphone, right? Whenever we go with the Nokia, it is like a keypad, mostly keypad or touch, right? Whenever it come with the Apple, they launched a smartphone. The smartphone can able to perform multiple options, right? Whenever they launched with the smartphone, they launched with their operating system, and such that they become very successful in the market in another 3 to 5 years. So in the end of 2010, Nokia, they don't know where they were making the mistake. Okay. So when they found the mistake, they started developing their OS, their own operating system. But when they launched it, it was like a total failure, right? So the process, if you see a person, a Nokia, which was successful, very successful in the mobile market, and started facing the downfall as because of they didn't properly predicted the future. So the future, it is again where they made the mistake is in the set of their design thinking. So the model thinking is also coming into the picture, which means in design thinking concept, they collected the ideas, but they didn't collected the ideas from different area. They just fixed their area, which means fixed their boundaries just to develop how best models. They forget to go with the operating systems where it will give the different features to the end users. Okay. So that was the best case study. Using that case study, later in the year 2012-13, Microsoft acquired Nokia, and they have very well used that case study of Nokia, and they always adapted the corporate culture in their product development things, and they always make sure that whatever the mistake Nokia has done, it should not be repeated. So like that way, they always focused great way, and then again and again they just made it with the clear launching of their products. So that's the reason they were always stick with the principle. So where you will need a speed boats before you can turn on an ocean liner, right? So you're supposed to have a speedboat. If you don't have a speedboat, it is not possible to cross your ocean liner, right? So that's the reason a good prototype should look great. So if you look at here, that concept is applicable in the engineering sector, especially in our case, we are mechanical engineering. If you look at the subtractive and additive, how this two process is having its own salient features, advantages, and all the things. So in that aspect only, now we are moving how the model thinking is again interlinked with the our engineering process. Okay. So if you look at here, the model thinking, how it was with the subtractive and additive. If you look at here, the first image, So this is the very famous temple in India. You can see also represented as the cave temple. So the entire temple architecture, it was carved from the a mountain. Okay, so the entire mountain they have carved like a temple. So when they go for these type of things, they should have the knowledge about the depth of mountain and what is the type of stones and all these factors. If they have a knowledge, a clear picture about all these things, then only it is viable. Okay, so this is how we have done. So here if you look at the concept, it's supposed to have a this much big mountain. If this much big mountain is there, then only this temple is possible. If not, again, the what is the level or what is the source you are having, according to that source only you have to limit your product. So this is the methodology in subtractive approach. Okay, so if you go for this, then you should have the fine tune tools, and you're supposed to have the knowledge, you're supposed to have the technology to understand the materials, the minerals whatever you are getting, and then the other resources and whatever the products you are having in and around. So this is the concept in subtractive. Whenever we move with the additive, so here it is the layer by layer approach which is going to build a technique, right? So here we are having the freedom to go for the design. So here we are not at all having any restriction. So the restriction what we are having here is design restriction. So only with respect to the product, which means the raw material size, we can able to limit our product size. Whereas in additive, we are having total freedom to go with any level of dimensional aspect, right? So this freedom should we get. When you are getting, then only your model thinking will give a more robust. Otherwise, we cannot able to say it is a robust and it can withstand in the market for a long duration, right? So this is the reason why our additive manufacturing are getting a more and more attention in nowadays. So whenever the additive manufacturing they introduced, right, they started building many things. So one among the thing is like they started building a bridge using the 3D printing. So here it is a 3D printed bridge, and you can see a large group of people standing and waving their hands on this. Okay, similarly 3D printed house, even in our IITs they done on 3D printed house and 3D printed car. So if you look at here, what we are getting is at the end we are getting the freedom with respect to dimensional aspect. So that freedom will give a more a prominent model thinking, which will finally gives or comes out with the best product among all others. Okay, so that's a day, that's a way. Now if you go for the additive manufacturing, how they are doing, they are normally, I guess these are all the various stages in the additive manufacturing. I hope you might be already having a very good knowledge about the additive manufacturing, and those who don't have, for them I'm just telling them how the additive manufacturing normally works. So the product will be first designed, right? So here we are designing as a CAD model. So whenever we are doing a CAD model, as I said, we are having the dimensional freedom. Okay, so whatever we are going to draw, we are having the total freedom to fix the dimensional aspect. So you can make it as a micro level, or you can make it as a macro level, or you can make it as a nano level. Anything, product size can be anything. Okay, so it doesn't matter. Only it is matter whenever we are going to build the 3D printing components. So what way we are going to use the tools, there only we have to concentrate. Rather than that, we no need to bother too much. Okay, so here this 3D printing, normally what they will be doing, they will be first starting with the developing the 3D model, which means the CAD model of the our component, what the component we need, and then that CAD model will be converted into a STL file, right? Then that STL files, here what is that standard triangle language. So if you look at that STL file formation, it is nothing but it represents a standard triangle language or tessellation language they used to say, right, in technically. And from that STL file, it will be again transferred where it will be sliced into number of layers, right? So the number of layers it will be converted. So my one product will be converted into thousands of slices. So it is just like I'm slicing the bread. A bread loaf, when it got sliced, it will be having the number of layers. Same fashion, my product will be sliced into an n number of layers, thousands of layers. Then each layer will be given as an input in my machine setup, right? So whenever it is going, the machine will be handling only layer, not the entire model. So we have to understand one thing. Here, the machine is having a freedom to select layer by layer. It doesn't matters what is the entire product to be. So it just fixed with the layer by layer selection. Obviously, you may be asking, the working area will be having the restriction, right? So the working area will be decided with the CAD design. So accordingly, we will be selecting our tools and techniques, right? But what here is the thing where the machine is going to interact and it is going to convert. So now the machine is having a freedom to select one layer after another layer. So when it is going to select a layer by layer, then it is trying to build the part as a layer by layer. So when it started building like that fashion, then I can able to achieve my end product in the fashion what I need. Okay. So that is the reason when you see the previous picture, the bridge, the entire bridge, what they have done, they have taken a layer by layer approach. After construction of each layer separately, then it was like build with each other. So this is the total layer by layer approach where it was built. So whenever we are having this freedom, right, then there is no limit for our innovations, right? Again, whenever we go for mistakes, the mistakes can be easily rectified here. Whereas when I go with my subtractive method, if there is a one single mistake, it will become totally difficult and it cannot be replaceable, right? I cannot able to repairable most of the time. It is a unrepairable mistakes. Okay. So whenever we go for additive, it can be easily repairable. It can be easily replaceable or refurbishable, right? So that way I'm going, and whatever the part I have built, and finally it will go to the end process. So this process cycle, if you look at here, how cleverly or how fantastically they are using the approaches. So it is designing, once it is the design is done, the slicings and then the selections, all the conceptual models are working very fine. So here the machine to machine interaction is excellent. When it is picking up one layer and it will start producing, and then only it will go for the next layers, right? So this is the thing which made additive manufacturing concept or this additive manufacturing tools as a grand success for the recent times. So because of that reason only, we are using these additive manufacturing concepts in many applications. And if you look at that, how this 3D printing, right? The 3D printing, why I'm telling is to make it you some simple language. So additive manufacturing, I'm just mentioning as a 3D printers, right? So if you look at this, how the graph shows is, right? So this is the things which will reflect how the market is giving importance to the new concepts, new innovations, new models, right? So this is mainly focused from the deriving the model thinking aspects, right? So what we discussed, whenever we started discussing about the model thinking, it will make to be a intelligent designs, right? So the model thinking, why do we need model thinking is to be an intelligent design, right? So when we go with this, we can find, yes, correct. It is perfect, intelligent. Whatever the model I'm giving, so according to my machine level, it is perfectly printing, right? If I want to produce a replica of my face, I can able to produce in 3D printer. It will produce. And if I wanted to produce a mouse, right, a computer mouse, I can able to. right? So this is the kind of intelligence it is having. So intelligent design, right? And then whenever we are using the model thinking, it will give the freedom to think very clean. So a clear thinker, right? To think very clear. How it is possible? It is possible by exploring many types of outcome and by means of identifying the logical boundaries and by efficient communication, right? So to think clearly means it's supposed to have all the things. So here the designer who innovated, who developed this additive manufacturing product, right, is adapting all these things, right? So after adapting all the concept and all the logical aspects, and he developed a effective communicative system which will work very finely, right? And the same way, because of that model thinking, we can say it use and understands the data, right? To use and understand the data means here when my system is converting a model, total model, into a number of layers, every layer is supposed to be a understanding data format, right? That STL file format, that STL file format is bringing my job done at a second. So when I am doing, it is using and understanding the data, and finally it is using the strategic way and design to finally produce my prototype. And all because of this model thinking only, that professional additive manufacturing concept is becoming a more interaction. And this is the graph shows how the usage of 3D printer is getting increased one year after year. Okay, so this is shows how the range of 3D printing applications is started exploring. So the more and more we started additive manufacturing concept, literally it is bringing down the cost of additive manufacturing tools, which means the 3D printer, right? So the cost is now started getting down, and if you look at these applications, the wide range of applications started increasing. Okay, so this is the one of the best example which I can say, the effective usage of model thinking and the implementation of model thinking and design thinking in their innovative product, right? So due to that, as because of at the beginning I told, right? So innovations can be happen in three ways: either by process or through vision. The third one is by luck. Okay, so whenever we started doing one thing, by luck we started getting another. So the same way that additive manufacturing is also, though it is a very good process based product, it is also bringing some type of luck. Like we are started producing multiple things, not only a specific industrial aspect. We are getting a wide variety of industrial applications, and especially a structural based applications using our additive manufacturing concepts, right? So if you go fine, right? So here I would like to tell one of the industrial application is turbine blades, right? So here, this is the gas turbine. So gas turbine, which is used in aerospace applications. If you look at the larger aeroplane, the aeroplane is, again, if you look at Concorde, the Concorde is having a very good dimensional space and everything. But due to its tail and its some problem with the wheel alignments, especially in the wheel when it is taking off, or whenever it is moving in the track, the wheel is made given some problem. So due to that reason, the Concorde flights are now totally suspended from passenger transportation, right? So in all these aspect, everything supposed to be designed very carefully. If we make one single mistake, it will be making a lifetime penalty for us. So same way, if you look at these engines, it may be at macro level for for public transportation, fine. We can go at any level. Okay. So whenever it was a military application, whenever we are restricting towards a military application specific, we can see the level of the engine supposed to be very small. The best example is unmanned aerial vehicle, UAV, we used to call, right? In UAV, if you look at the size of the everything is very small. And why do we need UAV, unmanned aerial vehicle? Normally for the surveillance purpose in the borders. So in our border, if you want to do any surveillance, and we have to make sure that there is no any trespassing from our enemy or any uh, other social unwanted elements, then we have to do unmanned aerial vehicle for surveillance. Whenever we are going for such type of a smaller way, smaller prototypes, then the additive manufacturing is giving a big hand with that. So whatever the component we are having, if you look at the component, I'm telling unmanned aerial vehicle itself a small in size means the engine supposed to be more smaller. When engine is smaller, even the blade supposed to be very, very smaller, right? So whenever we are going or narrowing the component more and more in a micron level or nano level, then the only viable solution we can get it from additive manufacturing, right? So compared to our conventional manufacturing, additive manufacturing is the only solution. Why? Because we have seen it is highly intelligent because of the very good model thinking when we brought it here. And with that, it is having a very good machine to machine interaction. And whenever or whatever the material I want to produce, I can able to produce using their machine learning concepts, right? It can interact with the system and it can solve my problem. So here additive manufacturing, what it is doing, interaction as well as solving my problem of producing this small prototype. And once I have done, then I can able to fix it, right? When I am fixing, what I am achieving here, unmanned aerial vehicle. So whenever I am going with the unmanned aerial vehicle, what is the main thing I am doing? It is a human centered. Why? If a civilian is sent to that particular post, which means he is posted into that locality, there may be a risk, health risk for him. Okay, he may be get injured or his life may be totally in danger in that place. Whenever I am going, but I cannot able to live as it is. I supposed to make sure that that borders are secured, right? So for that reason, what I'm doing, I'm just developing my small component, and I'm replacing the human with my unmanned aerial vehicle. So here it is the human centric approach, which is highly concentrating on a societal impact, at the same time how a human beings life can be survived, right? So with this only, the additive manufacturing and concept is totally related with the design thinking approach, where the design thinking and model thinking is interlinked. And that's the reason you can find how it is getting a visibility even there is some recession over a period, right? So whenever the machine, I mean the manufacturing concepts model was getting the initial bump, but due to some reason it may go lagging, but still it is getting the bump and it is getting bouncing back, and the industry is becoming even still healthier than before. So this is the one fine information we can able to say from the additive manufacturing concept, especially from the design thinking approach. Okay, so if you look at here, you can able to see what is the top 5 additive manufacturing startups over the period in various places. So these are all the top 5 startups which you can see. Just a second. Sorry for the break. Uh, so now you can see how the top additive manufacturing coming into the various sectors. So this is the top five startups, especially in the recent time in the medical sector. So when you are seeing that even in India is also one among the top five. Apart from that, there are a lot of things they have already started and developed. This is the data in the year 2020 in the month of May. So it is still going on. It is not at all ending in one point. It is still going on. If you see the additive manufacturing concepts. So here additive manufacturing has having different types. So we are not discussing or detailing about the different types of additive manufacturing. Rather, we are just focusing with what are all the companies adapting the additive manufacturing concepts. So here, so additive manufacturing, normally it is for all the type of products. So it can be for polymers, materials or composites, right? So any type of product, the companies are highly using or preferring the additive manufacturing. Why? Because it is very easy to design my model, right? And to get the prototype and for testing. Everything is very, very easy when I go with the additive manufacturing concept. Why? Because prototype and testing is the one of the main process in our design thinking. So why? Because with that prototype only we can able to get whether it is a failure or successful. And we said it is a iterative process. So every time it is like a loop. So as long as we fail more and more, we can able to fine tune our process. Okay. So in that aspect, here it comes out with the best solution for the prototype development, and with that prototype development they can go for the testing, and it is very easy and intelligent system where we can continuously feed our changes. So once the idea is fixed, right, so we can able to easily make some changes. And another main thing what we supposed to understand, the primary idea should not be changed. The idea supposed to be same. If you are keep on adding idea over another to totally different product, which means the end product idea again and again you are increasing the features, then it won't lead a feasible product. Okay, so the idea is supposed to be for a confined product. So what I need, I want a one computer mouse. So that mouse supposed to be used for this application. That's it. So how we can go for aesthetic look, how the features, everything can be discussed. We should not add like the mouse can be again used along with my laptop at the parallel time. It can be shared with the virtual. Those things we should not include additional features. If we do so, then the iterative loop will continuously goes on going, which means the lifespan will be increasing. We cannot able to complete the project within the duration. Okay, so these are all the other things. So in design thinking process they will clearly specify what they need. Okay, and that's the reason when they do the brainstorming, in the brainstorming they will come with a very clear cut idea. So what they will do in brainstorming, they normally listen and then they will go for the defining the judgment. There won't be an argument. No argument will take place. There won't be no ego or no certain things. Okay, they always go for the quantity, and they always go with the precise and somewhat like convincing way. Okay, so only one idea supposed to be taken at a time and then it will be processed. So that's the reason here a lot of companies they are just preferring with the additive manufacturing concepts, and with respect to their material they are choosing what type of things they want. Okay, so that's the reason additive manufacturing in the medical sector, nuclear sector, or in the defense sector, everywhere they are started using a very highly effective manner, even including a food processing sector. Okay, so here I'm just stopping my session. So this is about the model thinking, how the model thinking is connected with the additive manufacturing concepts. So with respect to the additive manufacturing, I have published some few articles uh, with respect to polymer as well as metals. So metals in titanium and nickel, as well as in polymer PLA and ABS types of polymers we have done. So these are all the approach we used in an effective manner with the additive manufacturing concept. And here we have used the design thinking approach to develop our model. So the design thinking approach where we have used with respect to metals, we have used in the turbine blades. And when we go for the polymers, we were started developing our models for various industrial applications, and one among that is for medical implant for uh, jaw, especially for tooth replacement, or sometime in the inside the body for bone replacements. Okay, so those things are still under research level. So we have just published our initial workout, what are the things and everything. So this is about our today's session. So here I am stopping. So now I request our session coordinator, Tyagarajan sir. Sir, Tyagarajan sir.
Sir, thank you, sir.
Thank you, sir.
Thank you for your wonderful presentation. You are nicely associated with design modeling, 3D printing, as well as additive manufacturing.
Sir.
And you have done some in product which you have developed with additive manufacturing. It's really interesting. Nice to see, sir.
Sir.
So now the session is open for the participant. Now you can interact with our expert. He's available with us. So if you feel any difficulty, you can post your question in the chat box. We are ready to answer you. So now the participant can unmute yourself and you can interact. So almost 126 participants are there, but we are not getting any questions.
Okay. So questions may be from any side. Why? Because here we just discussed how design thinking can be interlinked with the model thinking, and in what way the model thinking in the real-time applications, how we can, and how it is in the recent markets, everything we might be discussed. So if at all you are having any questions, you can ask, so we can discuss about that things also.
Sir.
Sir.
Yeah, Nikhil here from Maharashtra.
Sir,
your
sir.
Presentation was so nice and self-explanatory, so that's why we're not having any kind of queries to you.
Oh, thank you, sir.
But it will be great if you can share your the resources with the host so that they can share with us.
Definitely, sir. Definitely, I will share my material with a coordinator, sir. So, Tyagarajan, sir, I will send my presentation to you.
Okay,
and if
sir.
at all you want anything, you can also communicate with me to my mail ID. Anyway, our coordinator, sir, is having. So,
thank you, sir.
Thank you, Nikhil, sir. Sir, Ganeshan, sir. Sir, Ganeshan, sir, do you have any question? You have to unmute yourself.
M. Ganesan has raised a hand. Okay. So Ganesan, sir, are you available? M. Ganesan, sir. Okay. So Ramesh, sir, you have pointed out that the additive manufacturing is mostly used for food processing industry.
Yes, sir. Yes, sir.
So what type of things they are developing, sir? In which particular component or any?
Yes, sir. Yes, sir. Actually, if you look at the food processing industry, normally, whenever we go for especially in machinery, sir, in machinery or any machine product or anything. So whenever we go for that, normally food process, how can we say, whenever we are processing for a packing or anything, right? So those places, the components which are involved, if it is a metallic components, sometimes it may be reacting with the foods. So because food again, it is having a kind of chemical reactions with the metals. So to avoid that, we may be using as a any metal tools in that locality, especially in the machineries. So same way, in many places we can find additive manufacturing concept in a food processing industries. So normally for developing a machines, right? So when we go for the machineries with that, it is a useful way for making processing of food, right? So that way we can find it, sir.
Okay, sir. Thank you, sir. Thank you, sir.
Yeah.
So any other questions, sir? The kind request, please feel to interact. Okay. Criticality.
I hope there was additive manufacturing session in previous day also. Am I right, sir? Thiagarajan,
Yes,
sir?
sir. Yes, sir. Yes, sir.
Okay, okay, okay.
So 2 months before we have conducted a webinar series.
No, sir. I guess in the same design thinking program itself,
Okay.
in the brochure I've seen, one day you had additive manufacturing from CIT professor.
When, sir? Actually, when it
Maybe
is?
yesterday or day before yesterday, 2 days before, second day.
Okay, okay.
Okay.
Okay, sir. I
Good.
think
That's great.
Dr. Rajesh Ranganathan from Coimbatore Institute of Technology.
Yeah, maybe. Yes, sir. Yes, sir. CIT.
Yesterday, the day two only, he has just highlighted his area in medical applications.
Yes, sir. Yes, sir. So nowadays, additive manufacturing is finding wide applications. So especially in medical field, now the people are started finding best one to develop. How do we say bone replacement in all the aspects? Because
Yes.
3D printing is best solution to come up with the customized design. So when we go for a customization, very easy customization, that to intelligent aspect, the system is very intelligent. It can reproduce the same level of the client requirement. So why? Because the human bones, it may vary with person to person, and the thickness, consistency, and the strength. According to that, we can able to define our printing, which means the additive manufacturing. That's the thing.
Any software which is available, sir, for making
Sir?
the software which is available?
Huh. For this 3D printing, sir?
Yes, sir. Yes, sir.
Yes, sir. Software actually, open source is available, sir. Open source softwares are available for basic level of 3D printing design. Whenever you are going for industrial based, which means the 3D printer which was used in industrial applications or industries, they might be having their own softwares most of the time. So
Okay,
normally
sir.
Cura is there. The Cura which we are using here, so which is open source only, Cura
Okay.
software, uh, which may be used for initial design or designing our model. So CAD model, almost literally it is just like a CAD model.
Okay, sir. Okay, sir. So we have 2 questions in the chat box, sir. Can
Sir,
you read it or I can read?
yes, sir, I can see this. Design
Design
thinking work in refrigeration and air condition area. Okay. So design thinking in a refrigeration and air condition area. It's actually very good. Whenever we wanted to use design thinking, then I can say your heat transfer and finite element methods. These two concepts supposed to be brought together here whenever we go for any model thinking. So whenever we were using, I guess I'm addressing to Dr. T. Kumaresan sirs. Kumaresan, yes. So sir, here it is mainly for thermal specific. When you are having the approach with respect to design thinking, then the model thinking supposed to be linked with your two areas. One is heat transfer area and another one is mainly from your finite element method area. So in both the places you will be collecting, because finite element method for non-structural elements. So where we will be discussing about the heat flow and the conductivities, those things. So that approach has to be collected, and your knowledge in heat transfer, refrigeration and air conditioning, that has to be collected. Using that, you can able to produce a viable model which will be helpful to develop a prototype uh, compared to the existing either air conditioner or refrigerators. You can able to develop a fine model, and where it will be working with less cost, or it may be consuming less energy, electrical energy. So like that. So even whatever we are saying, whatever we are seeing energy conservative refrigerators or air conditioners, all are using that type of models only. Those things are uh, derived from the this type of model thinking and design thinking concepts only, sir. Oh, I hope I might have
I
addressed
think,
your question.
I
So
think,
next question, does design thinking work with all subject areas? Definitely, sir. So it is from question from Professor Vimala. Yes, Professor, definitely we can say yes. And that's the reason we are bringing model thinking here. So design thinking is like a generic term. We can say in a work location how it would be, or in corporate how it would be, or in academic how it would be. But if you come to the model thinking level, any subject you can bringing into the model thinking. This model thinking will be considered as a system thinking, engineering system thinking. So that EST can be, again, it is also a subset of design thinking. Definitely you can bring whatever the subject you want in an engineering way, you can bring it in the design thinking. Okay, I hope I might have answered you, Professor Vimala.
yes, sir, yes, sir. It's clear, I think. And one question,
Next is
types
from
of
P.
additive
Kaur.
manufacturing.
Yes, I have had some connectivity issue, so can't really enjoy. Okay. Types of additive manufacturing. Okay. From Sithanathan. Yes, sir. So Professor Sithanathan has given asked a question: types of additive manufacturing. Sir, types of additive manufacturing we can define as per ASTM standard. It is 7 different types. So it may be like how can we say stereolithography or laser sintering. So like that it will vary. Fused deposition modeling. So it is having a different. It is totally 7 different types. That 7 different types, if you want to explain, means again it will be come with the beginning. So based on polymer, how we are processing. Either we are taking a polymer in the form of powder or liquid, or like wire strips. Accordingly, we can categorize the different models. So it is totally 7 different types, sir. And okay, sir, Tyagarajan sir, I guess almost all the questions are done from this side.
Yes, sir, yes, sir.
Yes, sir. Sir, I will share my presentation content to your mail ID, sir.
Sure, sir, definitely, sir.
Yeah.
I will share to all the participants. So what are the PPTs you are getting from the speakers? We will ready to share.
Okay, sir. Okay, sir. Thank you so much.
So thank you. So we are almost end of the session. So once again, thank you, Dr. Ramesh Raju, for accepting an invitation and presenting a wonderful session.
and he also highlighted some of the work what he done previously. Definitely we enjoyed the session, and he also clarified some of the doubt issued by the participant. So thank you, sir.
Thank you, sir. Thank you, sir. So here I would like to thank the principal, sir, and director and HOD of Mechanical Engineering Department from Sri Manakula Vinayaka Engineering College and Technology, Cherry, for giving me this opportunity. And I would like to give my special thanks to Professor Tyagarajan, sir, for accepting and giving me a chance to make my presentation in your ATAL FDP program. And I thank all the participants for effective participation and asking the questions so that I can able to share my views. So thank you all. Thank you once again. Thank you all.
Thank you, sir. Thank you so much. So now I kind request to the participant, you kindly fill the feedback form which is posted in the chat box. So don't leave without filling the feedbacks. It's mandatory for getting the e-certificate. So thank you, Ramesh, sir. If you wish, you can sign out, sir.
Yes, sir. Thank you, sir. I'm just leaving, sir. Yeah.
So one kind information to the participant. So what are the PPTs which we are getting from the speakers? We are ready to send you through your registered mail. So because a few of the speakers are not in position to give that PPT because it's purely a research-based content. So I hope you understand. So what are the PPTs which we have from the speaker? We are ready to share you to your registered email. Thank you.
Good morning, sir. Gurpreet this side.
Ma'am, good morning,
So,
ma'am.
yeah, I really understand, sir, that some of the professors and people are,
Yes, yes.
sharing their research work. I totally understand that. In that case, I am sure you would be, somewhere putting up these recordings. If you can
Okay.
share that link, then we will,
Okay.
yeah,
You will
we'll be able to go there and revise the concepts. Like today,
definitely.
it was a network issue at my end, and still now also, I mean, my voice, I don't know, I'm getting breaking voice, but then I did manage to attend the session, but could not follow it or enjoy it thoroughly as the resource person was so passionately talking about. I could
Oh,
make out the passion, but I was not able to follow it. So really
yeah.
appreciate if you can share the recording link. That would be
Okay, ma'am.
really
So
helpful.
already we got a 2-day recording session. What we the last 2 days we have got it.
Wonderful,
We
wonderful,
are
sir.
yes. We are ready to share you the registered email, ma'am.
Yeah, please do it on the
Definitely.
registered email. That would
And
be really great. Big
thank you,
help.
ma'am. And one
Thank
kind request to all the participants. The next session will be follow on 11:45. Professor Shashli Kakri. He is having a good exposure with design, modeling, and innovation. And he's also ready to highlight some of the MSME funded projects and IPR related concepts. So try to make
Okay,
to
sir.
try to make to attend the session. It's very useful.
As madam told, please send all the recorded presentations to us.
Definitely, sir.
Thank you. Thank you
We
very
will
much.
ready to share it to register email, not in the other format, sir.
Okay, sir.
So don't
Okay.
expect in the WhatsApp group or some other thing.
Uh,
You will get the registered email only.
okay, sir. Okay. Very good
Thank you.
arrangements you have done, sir.
Thank you, sir. Thank you, sir. Thank you.
Okay. Thank you. Thank you.